Adil, you can start now.
Apologies for the technical glitch, guys. So sorry. Adil, you can please continue the presentation.
What was the last slide you people was able to see? AWS data building platforms?
The data as a service
Yes.
slide.
Before that, yes, this one.
Okay. Let me explain it again. So there's another interesting fact. Basically, the concept that is being on the cloud side is data as a service. So what is the basic concept? We need to understand data as a service concept on cloud side, how we can utilize. For example, so the concept is to store all the enterprise data on cloud and apply the integration, required integration transformation there. And once the data is prepared, load it into the final repositories, which can act as a knowledge base for the whole enterprise. And obviously this data is available through the internet as the different software as a service available through the internet. So what are the advantages basically? In this way, the enterprise data will become more accurate, highly available, more secure, highly integrated, and then more reliable. So what are the benefits? What are the advantages of having, Daas over the on-premise setup is basically the minimal time setup, greater flexibility, greater reliability, greater performance, and greater availability, obviously improved functionality and cost saving. Then we have the automated maintenance on the cloud. That is also a very good part, advantage, and then smaller staff requirement. So one of the best use case these days is basically AI-based COVID-19 detection solution. So it's image recognition based advanced algorithms which basically can be utilized to basically analyze the lungs of a patient. So the solution is based on high GPU based compute instances and core engine that is written maybe in Python or something. Then we have the object storage and API call. So basically the hospital collects the data from the CT scans and ship it data to the API. Now the API basically ship the data to the core algorithm from where these GPU based compute instances can utilize and give the result back to the hospital. And once the results are there, the hospital can map it to the result of the patient recovery model. So when you see the architecture, these infrastructure using basically GPU-based compute instances. So to acquiring this on any kind of the on-premise setup or in a private data center is very difficult. So AWS is a platform which has the availability of these high capacity compute things, and we can leverage all these services on the AWS cloud. Now let's get back to the typical solution design of data analytics solution. We have different 4 layers. Every layer is basically specialized, and the information basically flow from left to right. So the data sources layer is basically the layer which basically hosts all the sources that an enterprise basically have. So the second layer, the ETL, that is the preparation layer that collects the data from the sources and prepare the data and load into warehouses. So these warehouses can be corporate-based warehouses that they can be data marts, they can be summary tables, and these summary tables or warehouses can refer into the presentation side. So different presentation softwares can be utilized to collect this information from the warehouses and trigger their dashboards as per the requirement of the enterprise need. Also, some additional services that are available in the form of data mining for, you can say, predictive analysis or diagnostic analysis available there, you can use as per the requirement of the enterprise. Now, for the cloud point of view, usually the data that is being produced on the cloud side is basically referred to the big data. So some additional layers are required in this. For example, the ingestion layer. Ingestion layer are the basically specialized array of services that are able to collect the information as per the source of the information. For example, for IoT, we need to have some specialized ingestion services that can collect the data in a form of streaming data. Similarly, for the microservice space, we could have a messaging queue system which can refer for this. And again, for mobile API data, we have the specialized API source available on the ingestion side that can basically collect the data and then store the data into storage. So storage, again, on the storage side, we would have different variety, or you can say the array of services that can store the data as per the requirement. For like NoSQL, we have NoSQL databases. For SQL based, transaction based, we have transaction based databases. And if the requirement is to store the data in object storage, then object storage is also available. So once the data is stored there, it can be prepared in a different layer that can be referred as a preparation and computation layer. So it refers to the data lakes where the data can basically prepare, and through the batch runners and stream runners, this data can again load it into the warehouse. And from the warehouse, different presentation layers can collect the data as per the need. And similarly, the ML services, again, would be using the same repository for the ML services. So why AWS? So when we talk about AWS, so I would say AWS is state-of-the-art platform with array of required services that can be utilized to build the data analytics solution cloud as per the requirement. So you can see we have the collections there, array of services available that can be utilized. Store at store side, we have all the big data type storage, compute are available. Then we have analysis side. So store and analysis side basically share the data in between, and then we have the consumption side. So any third party, or we have the different service available within the AWS that can be utilized to produce the visual story. So now I would like Rohel to give you a detailed insight of AWS data services, which can be used to build data analysis solution on AWS cloud. Thank you.
Thank you, Adil. I will present some of the AWS services which you can use according to your use cases. AWS provide a lot of services that can collect, store, manipulate, and visualize the data. For example, some of the database services we have RDS, Dynamo, Redshift. For storage, we have multiple options like S3, block storage, elastic file storage. And for analytics, we have Kinesis, Glue, EMR, Data Pipeline, Athena, etc. So for databases, few popular services provided by AWS are RDS, DynamoDB, and Redshift. RDS is fully managed, highly scalable, highly available relational database service provided by AWS. It supports PGSQL, MySQL, MariaDB, Oracle database, and SQL Server database engines. RDS is easy to deploy. With the few clicks, your database server will be up and running in few minutes. RDS also provides automated backups and detailed monitoring for troubleshooting and optimization of performance. RDS has a billing option of pay-as-you-go and reserve instances, which allow to save cost by choosing the billing method according to your use case. The other is DynamoDB. AWS DynamoDB is fully managed key value and document database that delivers single-digit millisecond performance at any scale. DynamoDB can handle more than 10 trillion requests per day and support peaks of more than 20 million requests per second. AWS provides a user-friendly interface for the user to manage the data without worrying about the underlying hardware. AWS DynamoDB provides on-demand and provision capacity method for billing. Redshift. AWS Redshift is a fully managed, highly scalable, available data warehouse service in the AWS. Its datasets range from hundreds of gigabytes to a petabyte. Redshift is a big data service which provides huge amount of storage for storing petabytes of data. In Redshift, there are no upfront costs, no long-term commitments, and no demand pricing structure, which means you only have to pay for what you use. For storage, we have multiple options, and we will elaborate about the S3, which is a multi-purpose and powerful service provided by AWS. S3 is a scalable, high-speed, low-cost service designed for online backups and archiving of data with your application programs. It allows to upload, store, and download any type of file up to 5 TB in size. Amazon S3 integrates with other AWS services like AWS CloudFront, CloudWatch, RDS, AWS Kinesis, DynamoDB, etc. Using S3, the user can store a large amount of data at very low cost. The next section will be data orchestration. For data orchestration and manipulation, we have some popular options, which are Data Pipeline and AWS Glue. Data Pipeline is a service designed to make it easier for user to integrate data spread across multiple AWS services and analyze it from a single location. AWS Data Pipeline helps you easily create complex data process workload that are fault tolerant, repeatable, and highly available. You don't have to worry about ensuring resource availability, managing inter-task dependencies, or timeout in individual tasks. AWS Glue. AWS Glue is fully managed extract, transform, load service that makes it easy for the customer to prepare and load their data for analytics. You can create and run an ETL job with a few clicks in the Amazon console. AWS Glue natively supports data stored in AWS Aurora and all other AWS RDS engine, Redshift, and S3, as well as common databases engine which are running in your virtual private cloud in EC2 instances. AWS Glue is serverless. There is no infrastructure to provision or manage. AWS Glue handles provisioning, configuration, and scaling of the resources required to run your ETL job on a full managed scale-out Apache Spark environment. You pay only for the resources used while your job was running. For analyzing or processing your data, we have AWS EMR and AWS Kinesis. AWS EMR, which is known as Elastic MapReduce, is a service that provides a managed framework to run data processing frameworks such as Apache Hadoop, Apache Spark, and Presto in an easy, cost-effective, and secure manner. It is used for data analysis, web indexing, data warehousing, financial analysis, scientific simulations, etc. EMR pricing is hourly based, same as pay-as-you-go method. AWS Kinesis is a managed, scalable, cloud-based service that allow real-time processing of streaming large amount of data per second. It is designed for real-time applications and allow developer to take in any amount of data from several sources, scaling up and down that can be run on EC2 instances. It is used to capture, store, and process data from large distributed streams such as event logs and social media feeds. After processing the data, Kinesis distributes it to the multiple consumers simultaneously. Amazon Kinesis is cost efficient for workload of any scale. Pay as you go for the resources used and pay hourly for the throughput required. AWS has some services for visualization and gaining insight for your data. In the category, we have AWS Athena and QuickSight. AWS Athena is an interactive query service that make it easy to analyze data in Amazon S3 using standard SQL. Athena is serverless, so there is no infrastructure to manage. You pay only for the queries that you run. Athena is easy to use, simple point to your data in Amazon S3, define the schema, and start querying your standard SQL. Most results are delivered within the second. With Athena, there is no need for the complex ETL job to be prepared your data for analysis. This make it easy for anyone with SQL skills to quickly analyze large-scale datasets. Amazon QuickSight. AWS QuickSight is a fast cloud-powered business intelligence service that makes it easy to deliver insights to everyone in your organization. As a fully managed service, QuickSight let you easily create and publish interactive dashboards. Dashboards can be accessed from any device and embedded into your application, portals, or in your websites. With AWS pay-per-session pricing, QuickSight allow you to give everyone access to the data they need while only paying for what you use. Now Hassan will demonstrate a use case using AWS services. Over to you, Hassan.
Thank you, Rahel. So before we begin with the demo, let's just revise how a typical data analytics solution might look like. You have some data sources such as APIs, some files, some ERP systems, etc. And traditionally, an ETL or an ELT is applied to the data to make it ready for your data warehouse, on which some reports and dashboards are created. Now, for each of these layers or services, AWS provides a variety of services, and your AWS architecture could take any shape. An example architecture could look something like this, where we have an API as a data source in the data source layer, and we use a Lambda function, which is an event-driven serverless compute, to consume the API and put it on AWS S3, which is an object storage like a file storage. We then have a data transformation layer where we apply an ETL job on our collected data and place it in our data warehouse using AWS Glue. The architecture is currently showing AWS RDS, but just as easily could be AWS Redshift, the AWS offering for a petabyte scale data warehouse. Additionally, one may also have some stored procedures running in the warehouse as part of the ELT for summaries or other transformations. There are a number of ways one may trigger the stored procedure in AWS, but in this architecture, it uses a Lambda function to trigger the stored procedure. And finally, we have a presentation layer where we use AWS QuickSight to create our analysis and dashboards. So let's see how we can implement this architecture in AWS. For the purpose of this demo, I am going to use AWS to analyze the current situation of COVID-19. Now, there are a lot of public APIs available which supply up-to-date information on COVID-19. I will be using one from the COVID-19 Trakker available on Postman to create this model. The response has a structure as shown here, where you get timestamp when the records were updated and a list of countries with their statistics as to total cases, total recovered, and the cases per million population. So let's move ahead to the AWS console and deploy and create this model. So to start off, we have the API ready and we are moving into the Lambda service, and we are going to create a Lambda to ingest the API. We simply go into create function, and from here we have a couple of options. We can choose to author our code from scratch or use a template or blueprint provided by AWS. It needs some basic information such as the function name and the runtime environment. AWS provides a variety of runtime environments such as Node.js, Python, Ruby, Java, etc. So you can choose any runtime environment where you are comfortable in. Additionally, you will also need to provide an execution role, the role with which the Lambda will execute. And it should have sufficient privileges. For example, we want to write to the AWS S3 bucket, so it should have the permission to write to S3. Now I have already created my function, and I'm just going to be triggering it. The setup of it's written in Python 2.7, and the setup of the my Lambda function is pretty simple. I have my endpoint configuration where I define the API. I have my S3 configurations, so I tell it where the endpoint or the bucket is, and I simply make a request to the API. I get the result and transform it into comma separated values. I get the current date, and finally I put the data into the bucket with the current file name as the file name with the current date. So if I go to my S3 bucket, you can see that there is no file with today's date in it. And if I trigger it, or if I execute my Lambda function, you can see here once I refresh my list that there is today's data captured from the API. And I can look into what the file contains right from within the AWS console. So for example, if I want to see my preview, I can see that this is a sample of what my data would look like. Now, moving this data from S3 bucket to the RDS, we are going to use AWS Glue. Now, the Glue contains a list of ETL jobs, right? And I'm just going to trigger this one. And I'm going to explain what is actually happening. So before you can actually use AWS Glue, you need to be familiar with what it provides. And it basically divides into 3 sections: the data catalog, ETL, and security. And you may need a minimum of data catalog and ETL to perform or write jobs. The data catalog is basically a collection of your schemas and your connections to your data stores, your sources and your targets. And you will need to populate a list of tables from where you have to get your data. Now, an easier way, you can simply write your own schema, but an easier way is using crawlers. AWS Crawler is basically a functionality that AWS provides where a crawler can simply go into your data store and scan for any schemas, scan for files or tables, and collect all of the schema information and put it inside your data catalog. So let's create a crawler. Let's say S3 crawler. You can add additional settings such as tags, security configurations, but which are optional, so I'm going to leave them as it is. I'm going to crawl a new data store. The data store of my choosing, I can choose in a list of options. I can choose to crawl my S3, I can choose DynamoDB, or I can use the JDBC to just about crawl anything, such as my RDS. I'm going to crawl the S3, and I'm going to give it the path where it's going to crawl. So for example, I have this bucket folder where I have all of my data, and it will crawl and find schema for each of these files. Now the crawler is intelligent enough that if the files match the schema, it's going to create one table for it. But if my files have multiple schemas, it's going to create multiple tables in my data catalog. I can choose to exclude some files, but I'm not going to. And I'm not going to add another data store. Now, when my crawler runs, it needs a role or permissions to be able to run. I can create a role from right here, or I can choose an existing one. I already have an existing one, so I'll choose that. I click next. It asks for a frequency, how often to run this crawler. I can choose hourly, daily, or run on demand. I'll choose run on demand because I will not be making any changes to the schema. And I can choose where to put my data. This database is basically the collection in your data catalog, a database of your schemas and your connections. You can add the database from right here and create a new one, or you can choose if you have a separate one, so you can easily manage different projects or different services that you are working on. You can add a prefix to add to your tables. If you use one database, you can separate them using prefixes, etc. And then you have some optional settings here, which I'm not going to go into right now. Finally, you can review all of the information that you provided, and you click finish. and the scroller will be created. Now you can run this scroller and you can create all of the schemas from within the file. And as you can see, I have a list of crawlers already, and I have already set them up to crawl my data stores. So I created a crawler for my RDS, and I created a crawler for my S3 bucket. As you can see here, the S3 location, it found CSVs, and my MySQL engine for RDS. I have Trakker from CSV, and I have COVID draw from my DB. Now once I have my data catalog filled, I can simply go into ETL section and create a new job. So for job, let's give it a name. Trakker Performer. Again, it needs a role to execute. I already have a role. Now, for the engine type, AWS provides you a couple of options, such as Spark or Python shell. It's basically the engine which will execute your job. You want to use Spark. And again, if you may or may not know, Spark jobs can be written in multiple languages, such as Python and Scala. And AWS Glue provides you to choose your language option as well. I'm going to use Python 3. Further, just like Lambda, AWS Glue gives me the option to use a script provided by AWS Glue, or I can choose a script that I already have written, or I can author a new one. So I can use a script that is already provided by AWS Glue. Additional settings include my script file name, my S3 path where my script is going to be stored, and my working directory where my logs are going to be kept. You have additional options such as monitoring and etc., but I'm going to leave them as it is. And I click next. Now I need to choose a data source. So I need to choose my S3 as my data source. I click next. I can choose my transformation type. So I can choose to find matching records and delete duplicates, for example, or I can just simply change schema, and I want to change my schema. Now I have to choose a data target. I can create a new target right from here, or I can use the one I had crawled earlier. So I want to use my MySQL RDS engine, COVID draw. I click next, and now it's asking me to provide mappings. The Glue is intelligent enough to capture your mappings, which it finds best. However, you have the option to choose your mappings if AWS Glue made a mistake. And you can simply click here and choose your mapping. It looks fine to me, so I'm going to leave it as it is. And I'm just simply going to go and edit my script now. And it's provided me a sample script from AWS, where it basically takes data from my source, the Trakker, applies different transformations to it, and finally puts it into my RDS system. And I can choose to add transformations with a click of a button, such as I want to drop fields, I want to drop null fields, I want to map differently. I'm not going to be doing that, and I'm just going to save it, and then I can just run my job. Now, I already have created my job. And as you'll remember, when we came into ETL, I started my job as soon as we came in. The reason for that is because AWS Glue needs a minimum of 10 minutes to run the job. And as you can see, it's still running. The reason for this is the Glue takes up resources as soon as a job is triggered and not before. So right now, it's collecting the compute resources, the storage resources, it's making connections to my data stores to be able to perform the ETL. And it's going to be take some time. But what will it actually do is it's going to move all of my data from my S3 into my RDS, which I have made a connection with here. And it's going to input the data into COVID raw table. A sample of that table would look like this. This is a sample row. Now, additionally, there are procedures, or there are instances where you have additional stored procedures to be able to help you in your ELT. such as I might need to transform this data further and update my schema. For example, this last update date field is not analyzable. It's in a string format. I would want to change it into a format that is I am able to analyze on, such as date syntax. For that, I have written a store procedure. And I can call this store procedure right from within the AWS console. And there are a number of ways where I can call this from, such as I can use the AWS Data pipeline to trigger a SQL activity and run my script. Or, as I showed you in our architecture, we're going to be using AWS Lambda. So while this job runs, let me quickly show you how my Lambda looks like. So I already have my Lambda prepared. And again, it's a fairly simple script that I've written. It takes up the libraries. I have my RDS configurations. I create a logger. I connect to my RDS instance with my RDS configurations. And in case of an exception, I just log the error. And finally, in my main function, I simply connect using my connection. And I simply call my procedure. In case there is an exception, it will raise, and again, if it's not, it will return success. So the reason for making this script simple is, as a best practice for Lambda, you should limit your resources or compute time to as little as possible. To go for that best practice approach, I've made my Lambda script simpler and modular. Now if I go back into my AWS Glue log, you can see the job is now running, and it's now taken 38 seconds to actually execute my job. Now my job takes about 1 minute, as I can see from my history, and I'll just show you from my source. So for example, if I run my query on my table, you can see that my COVID raw has 0 columns. My COVID data has some 150 rows. And if I go back to my ETL AWS Glue, and I refresh my list, it will finish executing. So while it's still executing, let's quickly run over to our architecture and revise what we have done so far. So we have our API. We have a Lambda function where we ingest the API and put the data into the S3 bucket. We use the AWS Glue to move data from our S3 bucket into our RDS. And finally, we have a Lambda function to transform the data in our RDS into a format available for analyzing. So it's pretty straightforward and pretty simple process right from within AWS. And if I look at my AWS Glue job, it now says succeeded. If I was to run my query again, I can now see that I have about 200 rows that was taken from S3 and put into my RDS. So to run the procedure and make this format more available or analyzable, I'm just simply going into my Lambda function, and I'm simply going to be triggering my Lambda function. Execute, and it returned success. What it basically did was take the information from COVID raw and put it into my COVID data. And if I show you the output, it looks something like this, where the last update is now ready to be analyzed in a more standard format. And now that my RDS is prepared and my data is ready to be analyzed on, I can simply go to the next step in my architecture, which is AWS QuickSights, and perform analytics. So let's go ahead into QuickSights. Now I will need to move my QuickSight into the region where I have hosted all of my data to be able to analyze it. I'm just going to move it to Oregon because it's where I have my analysis, and I can begin my analysis. And I can choose my data sets. As you can see, I have already configured the data set, but as an example, we can see here that QuickSight is able to connect to a variety of different data sets. So for example, it can query directly S3, it can connect to Athena, RDS, Redshift, it can connect to MySQL from another instances, some SQL Server, even Twitter, or even IoT analytics if you have some. So I'm going to choose it on COVID data. I'm going back to my new analysis, and I choose COVID data as my source, and I can create my analysis and perform and create my dashboards. So AWS QuickSight provide you a variety of services. For example, it has a lot of visual types, for example, and it's a pretty simple interface with a drag and drop model. So if I want to see my countries with my total cases, I can simply drag and drop, and it's going to show me the output. And I can even apply filters to it. For example, if I don't want to see this country named world, I can simply go ahead here and I can filter it out. I can resize and move my visuals accordingly. I can choose to add more visuals or even insights. Insights is where I can add some text, some code to run if a certain condition is met. I can add an image, etc. So for example, hello. And it will also show me a preview down here. Now, once I have all of my dashboards ready, I can make them published or available for my organization or external people as well. So I already have a dashboard prepared here. And you can do a lot of things from within your dashboard. Give it a title, give it subtitle, have some insights. So over here I can see the top 7 countries with active cases. USA has the most cases, my world map, and I can see data that from my recovery visual that Germany has the most number of recoveries. I can connect it to multiple data sets, and I can get my API news and get up to date on what the latest COVID news is. And then I can finally share this analysis via email with my organization or publish it as a dashboard. And this dashboard I can share with my supply chain team so that they can ensure a steady supply of resources. I can share it with my HR department and they can devise travel restrictions or some travel strategies. I can share it with my finance department and they can create some budgeting policies so that we are well catered to in the near future. And there you have it. You can create a simple or your very own COVID dashboard or any other data analytics solution using AWS. It's a single one-stop shop for all of your needs. So that marks the end of our demo, and let's take some time to actually answer some of your questions if you have them. So I think we are done with our webinar, and I hope it was informative for all of you, and I hope it was a bit of fun as well.
That's yes, totally. Thank you so much, guys. Thank you so much, the Vapor VM team. I think it was a really insightful session. Yeah, and for the ones who want to reach out to the session again, I will shortly be sharing the recording link to the Vapor VM team. You can get in touch with them, and you can get the presentation recording. Yeah. Thank you, guys. Thank you so much. Stay safe. Stay home. Thank you.